Hello guys, welcome back to Code Your Trade. This is the third video of the series. Let's go to the flowchart and understand what we'll be doing in this video. In the last video, we saw how we can get all the tokens we need and subscribe to Websocket and get tick data. In this video, we'll look into how we can process it and we will complete the first part of our strategy, that is to place a straddle at 9:30 am and place 30% SL for both the legs. And if any order is not executed, we'll close all the open positions. Now, let's get started with coding. In the last video, we discussed how event handler feed update function receives incoming data. While this data contains a lot of information, we are only interested in two specific pieces, the token and the LP, which is last price. To manage this efficiently, we'll modify the event handler feed update function to organize this data into two dictionaries, that is C Websocket and P Websocket. These two dictionaries will save the data in a token wise manner where the key is the token and the value is a dictionary containing both token and LP. We'll start by creating two variables. One is C Websocket, other one is P Websocket. We'll create these two variables as a dictionary. After this, we'll also import C token list and P token list. Okay. We'll have an if condition. We'll check if tick data is not none and tick data contains LP value, and we also have token inside our tick data. If this condition is met, we'll say LP is equal to float and we'll access the LP data. Initially, this LP is in string format, so we'll convert that to float, and for our else, we'll just return. Why do we want this if else condition? So in Finvasia's data feed, if the last price value is not changed since the last update, the feed will send none for LP. To handle this, we'll check if the LP is none before processing the data. If the LP is none, we'll simply skip the update for that token as there's no new price to store. This way, we'll only update C Websocket and P Websocket dictionaries when the LP has changed and a valid price is sent. After this, we'll create a try except block, try except, and inside our try block, we'll get the token. We'll say token is equal to int and we'll access this token inside our tick data. After this, we'll have an if block. If token is in C token list, we'll again check if token not in C Websocket. We'll create a new key value pair on this token. We'll say C Websocket and token is equal to a dictionary where it contains token and the last price. Inside the second if condition, the else block will be if C Websocket already has the token, instead of creating a new key value pair, we'll just update the existing LP. So we'll access the key by token. We'll also get the LP, assign the LP. We'll write the code P Websocket in the same way we wrote for C Websocket. So I'll complete this code. So this will be elif token in P token list, and for our except block, we'll say except exception as E, and we'll print there was an error updating dictionary. Now processing this data is done. Let's once print this data inside our while loop and check if everything is working fine. So we'll import the C Websocket and P Websocket inside our main function. Let's print both C Websocket and P Websocket. If you guys can see, both our C Websocket and P Websocket dictionaries are now in the key value pair where key is token and the value consists of both token and LP value. But this way we can get the LP value when we just have the token. After processing the Websocket data, it's time to code the order placement for 9:30 am straddle. We'll first start by importing the datetime package. We'll say import datetime, and now inside a while loop, we'll say now is equal to datetime.now and .time. This will give us the time, and we'll say target time is equal to datetime.time, and here we'll say 9:30, 0. Okay. After this, we'll check if now is greater than or equal to target time, and if it is, we'll say place straddle and SL. Now this is the function we'll write which will handle the 9:30 am straddle placement. It will also handle the SL placement once our orders are successfully placed. If there is any error while placing orders or SL, this function will handle by closing all the open positions. Here, if you look closely, the if condition will always run if the time is above 9:30. To handle this, we'll create a flag called first order placed, and this will initially be false. Here, we'll say and not first order placed, which is it is not true. Here, after our place straddle SL is run successfully, we'll set this flag to true. So by doing this, our if condition is only valid once, and this place straddle and SL function will only be called called once. Let's code the place straddle and SL function. Let's come to a top. Before the main function, we'll say def place straddle and SL. This function won't accept any parameters. Inside the function, we'll create a try, except and finally block. Now inside the try block, we'll print a line to distinguish our order placements. After this, if you guys remember, in the last video, we created a function called as getLTP, which accepts two parameters, the exchange and the index, and it returns the last price. So in order for us to place a straddle, we need to get the last price of Nifty, and we also need to get the ATM strike. Now what we'll do is we'll say Nifty LTP is equal to get LTP, and we'll pass exchange as NSE. We have already created a constant, and say const dot Nifty for our index. This will return us the last traded price of Nifty. Now using this last price, we can get the ATM strike. If you guys remember, we also created one more function called as get ATM Nifty, which will take a number and round it to 50. So that will be our ATM strike. We'll say ATM strike is equal to get ATM Nifty, and we'll pass the Nifty LTP by accessing the result from our get LTP. Now we'll write a generic function which will accept the ATM strike and one more parameter. If it's either call or put, that function will return us with a trading symbol which we'll use to place the order. Above the place straddle and SL function, we'll say get symbol function which will accept two parameters. One is the strike, the other one is option type. Inside the function, we'll say if option type is not in either of C, which is call, or P, we'll just raise a value error saying it's an invalid option type. Else we'll just return, we'll construct our trading symbol, so it will be Nifty. And in the last video, we also created an expiry date constant, so we'll take that. The next part of our trading symbol would be expiry month. After this, it's the year 24. After this, it's the option type, then comes the strike. Yes, inside the function we can now get C strike, which will simply be calling our get symbol function and passing the ATM strike with C, which is call. We'll do the same thing for put. P strike is equal to get symbol ATM strike and P. Let's once print this C strike and P strike and check if we are actually getting the correct C strike and P strike. We'll also print the ATM strike. We'll run this code. Okay, if you guys can see, the current ATM strike of Nifty is 24,700, and now we have both C strike and P strike. Let's go back to our function. Now that we have the correct trading symbol for both C and P, it's time for us to place the first order. Let's go to our Finvasia Python documentation and see how we can place an order. If you come to our documentation and search place order, it will show us a method. Let's copy this method and paste it inside our code. This method accepts multiple parameters. You guys can refer the documentation to see what parameters it accepts. Instead of calling the place order function directly like this, we'll create one more generic function which will accept all the parameters, and we'll place the order inside that function itself. That function will return the order status or error. Now let's code that function. We'll say def place order. We'll have a try except block. We'll say accept exception as E, and we'll return the error message. We'll also return what is the error which was caused. Inside our try block, let's copy this code and paste it. Instead of storing the result in a variable, we'll just return it. Let's format the parameter section. Here we'll pass buy or sell as a parameter, so that will be buy, sell. For the parameters, except disclose quantity and retention, we'll pass everything as a parameter. The function will look something like this. You guys can pause the video to check what are the parameter we're passing to place the order. Inside our place straddle and SL function, now we'll say place CE is equal to, we'll call our newly created function, and in this function the first parameter will be buy or sell is equal to const dot sell. We'll create this constant in our constants. We'll come here, we'll say sell is equal to capital S. This is how the cell is defined in Finvasia's place order function. After this, we'll pass quantity. Again, we'll create quantity parameter inside our constant. We'll say quantity is equal to, let this be 25. Product type MIS, which is I, price type market equal to MKT. After this, we'll create price type SL limit, which is equal to SL/LMT. We'll also create exchange NFO, where it is NFO. I think this is all we need as of now. Let's come back to our code, and the next parameter it accepts is product type, which is const dot product type MIS, which is for intraday. We'll say exchange is equal to const dot exchange NFO info. Next parameter will be symbol. This will be the C strike which we created. We'll pass that. Next parameter is price type, which is cost dot price type market. Next trigger price will be none because we are placing market order. Price will be 0. Remark will be CE sell. Remember, this remarks is very important. We'll see why it is further in the video. Our call placement is successful. We'll do the same thing for put. I'll just complete the code. Now when we run the program, both call and put order should be placed. The market is closed right now. Still, if you place an order in Finvasia after market is closed, the order will be rejected. This is fine because we just want to check if our order is getting placed. I'll run the code and I've logged into my Finvasia account, and if you guys remember, we have order update function from Websocket, so we'll get all the information which will be printed in our terminal. We can check our order status in terminal also and in our broker too. Let's run the code. Okay, the order is placed. If you guys can see, the current ATM strike of Nifty is around 24,700 and we are placing 24,700 straddle. In our order update, we can see the status is pending, and if we come to the end, the status is rejected. We'll go to a broker and confirm if both the orders are rejected. As we see here, we can see 24,700 call and put were placed for 25 quantity and both the orders are rejected. We'll continue writing the code now. The next part would be to validate the order placement. So when the order is placed, the status will either be okay or not okay. If you refer to the documentation and if you go to place order, here in the status section, if the order is successful, we'll get status okay. If not, we'll get status not okay. This means if any of our order is not at all placed, we'll get status not okay. We'll come back to our code. We'll check if place C is none, or we'll get place C dot get stat. If it's not equal to okay, it's a capital O, or not place P dot get stat is not equal to okay, we'll print an error message, and we'll introduce a new flag called as universal exit triggered is equal to true. We'll import this inside our place straddle SL. We'll say global universal exit triggered will come at the top, and initially this will be false. After this, we'll say universal exit. This is the function we'll write, where if this function is called, every position or every order which is open in our account will be closed. After this, we'll not proceed, we'll just return. We'll write the universal exit function in the next video. After this, we'll say time.sleep. We'll give 3 seconds. The reason why we are doing this is when we place this order, the initial status will be, I think, pending. Next will be open. Next will be complete. If we immediately proceed with our program, there might be a chance that our order is not yet complete. This may cause some problem in our code. So we'll wait for 3 seconds. After this, we'll call an API method called as single order history. Let's go to API documentation, see what this is. If we search get single order history, this will take Noren order number as a parameter and it will return all the information on that order. We are interested in average price and also token. We'll come back to our code. We'll say CE order status is equal to API dot single order history, and we'll say order number is equal to, we know if our place CE is successful, we'll have the Noren order number, so we'll access that, and this will get the CE order status. We'll do the same for PA order status. After this, from our API result, we'll get the token. C token is equal to C order status, and we'll access the first in the dictionary. We'll say token. We'll make C token a global variable. We'll say here, and at the top, our C token will be none. The same way, we'll create P token. This will also be none. We'll import P token too. Why do we need the C token and P token? We need both C token and P token in case of adjustment. So we'll get the tokens here itself when we are placing the order. P order status, access the first one and token. After this, we'll get the average price, which is the average price for our placed order. We'll say C average price is equal to float C order status, and we'll access the first one and we'll get the AVG which is average price. We'll do the same for put. Now we have both average prices. After this, we'll again check if our order is successfully placed. That means CE order status will access the first in the dictionary and we'll get the status. If it's not equal to complete, or if PA order status, we'll get the first one and we'll get the status is not equal to complete. We'll print an error message. After this, we'll make universal exit triggered flag as true and we'll call universal exit function. After this, we'll return. Why are we doing this twice? If you guys can see, we are doing it once here to check if stat is okay, and again we are doing it here to check if the status is complete. complete. So let's say our order is rejected. In that case also the stat gives us an okay. That will only give not okay when order is not at all placed or if there is any other error. Here we want to confirm that our order is complete and does not have any other status like open or trigger pending or rejected. So we'll check once again here and see if our order is complete. If this condition is true, our program will be stopped here and any open position will be closed. Now that we know both of our orders are placed successfully, we can proceed with placing 30% SL for both these legs. Just a reminder, I've taken the average price. This means if any other order was placed for the same strike, the average price will be different. If you guys want to get the price which was placed in this order, is just PRC instead of AVG PRC. For this example, I believe AVG PRC is fine. So we'll proceed. Now we'll calculate the trigger price and the price for our SL. We'll say CE trigger price is equal to, we'll create one small function called as rounded to tick and we'll pass CE average price into 1.3 which is 30%. We'll write this function. We'll come to the top, we'll say def rounded to tick. This will accept the value and here we'll return round, again round value by 0.5 because our value should be in multiples of 0.05 and into 0.05 with a decimal of 2. So if the CE average price comes around, let's say 25.17, we want to make sure the trigger price and the price will be in the multiples of 0.05 so that we won't get any error. For the price, we'll say rounded to tick and CE average price into, give it 1.45. We'll do the same for put. After this, we'll say CE SL order and we'll call a function place order which accept by cell is equal to const dot by. We'll create this constant, come to our constants and here after cell we'll say by is equal to b. Come back, this will accept quantity, const dot quantity. Product type is equal to const dot product type MIS and exchange is equal to const dot exchange info. Symbol is equal to C strike which we got at the top and price type is equal to const dot price type SL limit and price is equal to C price. Sorry, let's correct this. We'll get the CE price, pass it here, and next will be trigger price is equal to CE trigger price. And in remarks, this is very important. We'll pass CE first SL. This is how we'll track if our SL is hit or not. We'll see in the next video, and we'll do the same thing for put. Okay. Once our code is run till here, it will actually place the straddle, and if our straddle is placed successfully, it will place both these SLs. As the market is closed right now, we can't test this, but the code is correct. We'll proceed. After this, we'll do the same check we did at the top when we place the straddle for placing the SL order, which will look something like this. After this, we'll get the CESL order number by getting the status here, and we'll access the Noren order number. We'll do the same for put. Okay, and this order number will be a global variable. We'll come to the top and we'll say here, we'll also import PESL order number. And we'll go to the top, we'll say CSL order number is equal to none and PESL order number is equal to none. We'll come back to our function. After this, our first part of our strategy is completed. We'll just print the order number here just to check if everything was successfully completed till this part of the code. We'll say CE order number and we'll do the same for put. And in our exception, we'll say except exception as E. Inside this, we'll print the error message correctly. And if there is any error, we'll set universal exit triggered as true. And we'll call universal exit function, which we'll be coding in the next video. Uncomment the finally block. And if universally exit triggered, we'll print an error message. Okay. I think I left out one more important part. After the C strike, we'll store the C strike in a global variable. We'll call this first C strike, which we'll be needing in the future, is equal to C strike. We'll do the same for put. First P strike is equal to P strike, and we'll import this globally at the top, both E and P. We'll also go to the top, and here initial value of first C strike will be none, and we'll do the same for put. We'll come back to our function. Everything is done inside this function. The next part would be to write universal exit function, which will complete our place straddle and SL function. Thank you so much for watching the video, guys. If you like the content, please hit the like button and subscribe to our channel. See you guys in the next one.